Okay, so in this video, we're gonna look at this same example problem and talk about how do we set up more scalar equations by using acceleration equations. Okay, and we can start with this rigid body, this wheel AO here. And so we have different points on this rigid body AO. We can first look at point between point A and point C. We can apply acceleration equation between these 2 points A and C. This is how you set up the acceleration equation. But be very careful, this alpha only belongs to alpha AO, which is the wheel AO. And break everything down to IJK form. Point A, in my point A potentially could have both X and Y direction. So you have AX and AAY. AC, C, it's a special point, right? That's an instant center. This is special case number 1. So A, acceleration at point C, only has X component, only has Y component. Its X component equals to 0. That's what we learned from special case number 1. And alpha AO, that's alpha AOK, cross product with RA/C. That's a vector start from C, ends at point A. So it's RI plus RJ, and minus omega OA squared times RI plus RJ. Okay, then from this acceleration equation, we got 2 more scalar equations, one on I direction, another one J direction. And that's scalar equation number 11, number 12. And if you look at those omegas, omega AO, those omegas should be solved from the first 10 scalar equations by using velocity equation. Okay, so that's the first acceleration equation on rigid body OA. And you can look at rigid body AB. You can apply one more time acceleration equation to A and B. Same deal. Be careful about this X and Y components for each point. So for A has both AX and AY. For B, if you look at where B is the center of the wheel. It can only move left and right. So that's why I only put A, B, X, I here. A, B, Y here should equal to 0 because that point can never go up and down. So there shouldn't be any acceleration on up and down direction. And same here, alpha K equals the position vector. Be very careful that position vector start from B, ends at A. So it's negative DI plus RJ. If you're not sure how to get that, make sure you watch the first video. From this acceleration vector equation, we can get 2 more scalar equations, one on I, one on J. You see the cat here. This will give us 2 more scalar equations, 13 and 14. Again, those omega AB should already solve from all the velocity equations. Okay, so that's rigid body AB. Now we have one more rigid body, which is this disk. We can apply velocity acceleration equation one more time to point B and point D. B is the contact point, and break everything down to IJK components. B is going to only have X component. AD, D is contact point, so it has 0 X component. Again, this is a special case number 1, rolling on a fixed surface, no slip. And ADYJ plus alpha equals RJ minus omega BD squared RJ. Big R is the radius for this disk. 2 more scalar equation, one on I, one on J. That's scalar equation number 15 and scalar equation number 16. And if we continue, we can find more equations by using acceleration equation. So how? If we look back at this rigid body AO, we have this point is the center contact point and this special point that connects both AO and AB. So we can apply acceleration equation one more time between these 2 points, A and O. And that would be this equation. And you follow the same process, you should get 2 more scalar equations, scalar equation 17, 18. Also, you can apply acceleration to point O and point C again. That's another vector equation, going to give you 2 more scalar equations. So potentially, I want you to do this on your own. You can get number 17, number 18. From this equation, you can get number 19, number 20. So now you have it. You can get totally 20 equations from this problem. And that should be plenty or more than enough to solve the unknowns you need. Right? Hopefully you learned something. Thank you for watching.